Thanks everyone for joining the session. So today we are going to discuss about more important stuff, BGP loop avoidance mechanism. What is the biggest problems in routing? Loops. Okay. Because of the loops, you will see asymmetric routing, lot of things you will see. Okay. What is asymmetric routing? Everything we'll do that. We'll discuss today. Okay. We are going to discuss lot of stuff today. Okay. Let's discuss about BGP loops. Okay. Uh, I'm going to remove this. Okay. So what do you mean by loop? Loop means, can anyone explain what do you mean by loop in routing platform especially? Can anyone?
ఒక ఎగ్జాంపుల్ R4 రౌటర్ ఉందన్న. అదొక
Okay.
ఒక రౌట్ పంపించింది. అయిపోయి ఏదైనా ఒక రౌట్ పంపిస్తే మళ్ళా రిటర్న్ దాని దగ్గరికే రావడం
Very
లూప్
good,
అంటారు.
man. I really appreciate you. Even though you said in regional language, hats off to you, man. Yeah, that's correct. So whatever you send whatever you advertise the route to any router, right? It's again coming back to you. That is called loop. Okay. So this next stop is very important. Next stop means this is owning this route. So if you see here, right, this R4 is advertising this EBGP route. So it means 4.4.4 is advertising to R1 neighbor, and this 4.4.4 is carrying the next hop attribute. This is called attribute. It means next hop. So what is the next hop for 4.4.4? 1.1.1. No, no, no. Not 1.1.1. It's like, what is the next hop here? I changed it, right? Yeah. What is it?
14.4.
Very
14.1.
good. Very good. 14.4. It's a peer IP address. Okay,
Yes.
guys. In interview, they will confuse you. What is the next hop? Next hop means generally you will recall a static route. So you will tell simply next router interface IP. No. In BGP, the next hop means the peer IP address, the neighbor IP address, whatever the neighbor statement you use, right? That IP address 192.168.14.4. Please remember this thing. Interviewer can confuse you. So the next hop means the peer IP address. We used to call protocol address. Okay. So it means this 14.4 is the owner of 4.4 is 14.4, so that it is advertising to R1. So now everyone, it is. So now let's take one more router here. I'm taking a one more router here. This is what R6. Okay, let's do connectivity in internet. In internet there are a lot of service providers, right? Each service provider is connected to the another service provider. That's where the internet works. Now Airtel is connected to the, this is another service provider. Let's consider. Can you please name the service provider here? What name we can take here?
AT&T.
AT&T.
జియో.
Nice. Let's take AT&T. Mm, yeah. Okay. Let's take any light color here. Oh, yeah. This one is good. Okay. So you can say AT&T or SIFI Technologies in India, Comcast, whatever it is. So AT&T is biggest service provider in US. Okay, just consider this. This service provider will have a autonomous system number, right? Can we take real autonomous system number? Let's search here. AT&T a autonomous system number. Everyone knows what is autonomous system number, right? Each and every company
Yes,
has
sir.
their own autonomous system number. So what is the AT&T autonomous system number here? 7018 and 13979. Okay. Yeah, I'm just showing you. So just take 1 second. This is AS100, right? This is Airtel. This is Airtel. This is Tata. And this is AT&T. And what is autonomous system number we can take? 100, 200, 300. Next take 400. Just practice purpose. Okay. Yeah. Clear, right? Now, what network I'm going to take here between R4 and R6? Can anyone please tell me?
46.
Yes. Dot 46.0/24. And here, what network I supposed to take here?
56.0.
Good mark. 56.0/24. Okay, perfect. So let's configure the BGP later. Now I would like to tell you the problem in BGP, especially in EBGP. Let's talk about EBGP loop. Okay. So the BGP advertisement rule, okay, when you try to advertise a network from one AS to another AS, the protocol next hop will be changed. This next hop will be changed. But when a EBGP route advertised to the router R1 and R1 is advertising this route to their IBGP peers, when it is advertising the IBGP peers, right, the next hop will not be changed. That's why we configure next hop self. Okay, but everyone understood what is next hop self, right? We discussed yesterday. Hello.
Yes, yes,
Yes,
sir.
yes.
Yeah, yeah. So now the rule is when you trying to advertise a EBGP prefix to another EBGP peer, which is in different AS, when it's crossing the AS, right, when it is advertised from R4 to R6, the EBGP route is this. When it is crossing this AS to this AS, right? So what exactly it will happen? So now we have a attributes. What do you mean by attributes? Attributes. Suppose I would like to give you a real-time example. When you purchase a t-shirt, for that t-shirt will have a tag, right, yes or no? The tags, you will see the tags. So in the tag you will see what is the price and the barcode, what is the size of the t-shirt, what kind of material they use, spandex or polyester or cotton, how much percentage they mixed it, and where it is manufactured, the company name, the address. All this information you will see in tag, yes or no, right? Say
Yes,
same
yes.
like that. Same like that in BGP, when you try to advertise a route, right? It will carry the attributes. So what route you are advertising? Tata is advertising what route? 4.4.4 it is advertising. When it is advertising the route to any BGP peer or either IBGP or EBGP, what it will do? It will carry the tags. Those tags we call attributes. So what are the mandatory attributes it will carry? So mandatory attributes. So there are two types of attributes. Well known. Okay, let me share this PPT. It is having very good way. Okay, uh, not this one. One moment. PGP attributes. Yeah, this one. Okay. So yeah. So what are the attributes here? You will see well-known attributes. Okay, so attributes are two types: well-known attributes, optional. So in well-known attributes you have two types of attributes: well-known discretionary, well-known mandatory. Now let's focus on well-known mandatory here. So BGP attributes means tags. Each and every route will carry those tags. So what are those tags? Well-known tags, well-known attributes. In well-known you have a well-known mandatory. So what are the well-known mandatory here? What do you mean by well-known mandatory? Well-known means very well known. Okay. In Telugu, baga telisina. And mandatory means it's mandatory. మంచు లక్ష్మి గుర్తొస్తుంది నాకు. సో ఇంగ్లీష్ లో చెప్పాలంటే మ్యాండటరీనే ఉంటుంది. తెలుగులో చెప్పాలంటే ఇట్స్ ఖచ్చితంగా. సో మ్యాండటరీ. ఓకే, మ్యాండటరీ మీన్స్ ఇట్స్ కంపల్సరీ. ఓకే, వాట్ ఆర్ ద attributes the EBGP route should carry? Mandatory. Oh, what happened? Well known mandatory. One second, guys. Well known. Okay. What are the well known mandatories? What is next hop? Next hop attribute. Next hop attribute means neighbor IP address. Okay. Next hop attribute means neighbor IP address. Okay. And second one is AS path. And third one is origin. Okay. Third one is origin. Okay. So if you see here, right, these are the things. So origin, you will see IE question mark. What does it mean? I'll show you right now. So in origin, you will have I. I means internal. So if you use this command network and you're advertising 4.4.4, right? If you use network command and you're manually advertising it, right? You're manually advertising it. And if you manually advertising it, right, it will set I. Otherwise, this is a 4.4.4, right? This is 4.4.4, and this 4.4.4 is the IP address of loopback, and this 14.0 is the IP address of G1/0. these are the physical IP interfaces, right? They are directly connected. So what you can do, there is a command redistributed connected. It means whatever the directly connected IP addresses, right? So let me show you right now. This is R4. Okay. Show run section BGP. What you are doing here, you are giving a network command. If you give manually network command, right? What it will do? See here. This is R1, right? Show IP BGP. This is a BGP table. Oh, still BGP neighbors are didn't up. Show IP BGP summary. Yeah, it's up now. So show IP BGP. Come on. So it will take some time, network convergence time. See, it's up now. So it will populate table. Okay, fine. The thing is, the thing is, if you use network command, right, this route will select a I keyword. It's internally, it is generated. Origin means where exactly it came from. So you manually advertise it. If you use redistributed command, right, it will give you question mark. So that, so the route will prefer I greater than, E greater than question mark. Okay. So internally, if you manually advertise it, right, then the manual advertising network will be preferred first. Okay. Yeah. So these are the mandatory attributes which carry. So suppose Tata router is advertising a 4.4.4 to AT&T. So what route it is advertising? 4.4.4. What are the mandatory attributes it should carry? Mandatory, well-known mandatory means every router should carry these three tags, three attributes, and these three attributes should be understood by BGP router. It means this is a BGP router, this is a BGP router. This BGP router is sending a route with these three tags, and this BGP router should understand those tags. That's why it is mandatory, well-known mandatory. Okay. So now, next stop, one attribute, another one is AS path. What is AS path it is carrying? Where it is coming from?
100.
Yes, very good.
100.
100. That's correct. And now what is one more attribute it will carry? Origin, right? What is the origin now? I use network command. So it is I. Okay. Suppose if I see, right. So now it is saying that I. Are you seeing it here? I. I'm on R1. So it receives the 4.4.4. This is the next stop attribute. And what is the attribute? Another attribute. This is the AS path, and I means origin. In case I'm on R4, right? Let's do this thing. Router BGP. What is that? 100, right? Now, instead of using network, see, remove network, no network. Just I'm playing with 4.4.4. No network. Are you seeing my screen? Mask. I'm removing this. And instead of doing this, do show IP interface brief. If you see, right? This 4.4.4 is directly connected, right? If you see, do show IP route. This 4.4.4 is directly connected. It's it's directly connected. C means what? C means directly connected. So you can redistribute directly connected routes. You can use simply redistribute. There is a command called connected. Connected is also a protocol. Okay, directly connected. Just redistribute connected. It means what it will do, whatever the routes which are connected, right? Connected state. All the routes will be advertised into the BGP. Now, what are the routes which are in connected? 4.4.4 and then 14.0. These two routes. So now I just redistributed connected. I issued this command. Now it is a redistributed route, right? That's what will show you the question mark. If you see here, right, on R1, earlier it was advertised by using network command. That's why it is showing origin as I. Now it will show you question mark. Yes or no? Is it make sense? Is it clear, everyone? Hello?
Yes, sir.
Clear, right? Yeah. So I think this is a practical example, guys. We did lot of things at packet level. When I will come, when question mark will come, and the E means EGP protocol. We have only one BGP, right? So Yeah, we have administrative distance, so you won't see E much. You will see either I or question mark. Okay. Yeah. Now the difference is clear. So what are the mandatory attributes it will carry? Next stop, AS path and origin. Is it clear? Hello.
Yes, sir, clear.
Okay. Now this route is advertised to the AT&T. AT&T received it when it is tried to advertise the same route to Airtel route. So it is changing the AS path. Okay. It is changing the AS path. It is not advertising within the IBGP peer. It is advertising to another IBGP, another EBGP peer. So when the route is crossing to another route, another AS, right? Now the next stop will be changed. So now what will be the next stop here? Can anyone tell me? This EBGP route will be advertised to Airtel router, and what is the next stop value here?
46.600.
Just observe carefully. You are very close.
56.6.
Awesome. Fantastic. So R5 neighbor is 56.6 only, right? I didn't write here, but you understand the logic. So what is the IP? What is the BGP neighbor here? It's 192.168.56,
56.2.
56, right? 56.6, right? Here. This is 6 na, sixth router. So 56.6. So R5 BGP neighbor is 56.6. 56.5 is the R5 wala. Okay. Now carefully observe. So now the AS path is next stop is 56.6. And what is the AS path? So the AS path, what it will do generally, it is carrying the AS path, right? In BGP, if you advertise any route to another BGP peer, it will carry the AS path. Why it will carry the AS path? I'll let you know why it will carry the AS path. You will tell me. So now let's carry the AS path. Tata is sending to AT&T. It is carried its AS path as 100. Now, you know, AT&T is sent to Airtel. It is so carry means prepend. It will prepend the AS path. Prepend in the sense it will add one more route. So it is carrying, right? So what route it will prepend now? It will prepend 400. Okay. So prepend, right? Prepend in the sense it will be front. Okay. It will be 400. Okay. So this route is going to here because it is crossing this AS also. So it is coming from 400 as well as 100. Everyone understood this? Everyone? So whenever the BGP route is advertising to the another AS, right, it will prepare the AS path. So first Tata is advertising to AT&T, and when it is advertising, it is prepended its own AS 100. And now when AT&T is sending to Airtel, it is preparing AT&T AS number and 400. Okay. Now this route is again going to R3 router. Now R3 router receives it. What is the next stop here? R3 is in Infosys, right? Is in
200.
different AS. What
Would
is
be
it?
same.
No. Why? It is moving from one AS to another AS, right?
Okay.
R3 is in different AS, right? It is AS 200. So what is the peer IP here?
Ibrahim. 35.5.
Awesome.
35.5.
35.5 is the peer IP and it will prepare the AS. What is the AS?
300.
Awesome. 300. Now,
Previous ఏస్ కూడా దాంట్లో ఇంక్లూడ్
yes,
అవుతుందా?
yes, yes. That's what preparing in the sense it will prepare the each and every AS here.
Okay.
Why it is doing, I'll tell you now. Why it is preparing the AS path when it is crossing each AS. So you will come to know, okay, this 4.4 is coming from Tata, AT&T and Airtel. And now it is reached on Infosys AS number 200 and this router. Now this R3 is advertising to 1.1.1. Now you tell me, here I applied next stop self as, here I applied next stop self, here I applied next stop self. So now what it will do, it will apply next stop as 3.3.3. Yes or no? And will it carry the AS path? Why it is coming 3.3.3? Everyone understood?
అంటే 3.3కి 1.1 నైబర్ల కన్ఫిగరేషన్
No,
కదా.
no man. 3.3.3 neighbor ఎవరు 1.1.1 2.2.2. సో నిన్న మనం నెక్స్ట్ టాప్ సెల్ఫ్ కాన్ఫిగరేషన్ చేసాం కదా, ఏదైనా ఎక్స్టర్నల్ ప్రిఫిక్స్ వస్తే అది ఇంటర్నల్ బీజీపీ పియర్ కి అడ్వర్టైజ్ చేస్తుంది. అడ్వర్టైజ్ చేసినప్పుడు ఏముంటుంది, దే హ్యావ్ ది నెక్స్ట్ హాప్ అనేది మారదు. అంటే 192.168.35.5 మాత్రమే ఉంటుంది. సో దిస్ రౌటర్ డజంట్ నో హౌ టు రీచ్ 35.5. దట్స్ వై వీఆర్ కాన్ఫిగరింగ్ నెక్స్ట్ హాప్ సెల్ఫ్. ఇది నెక్స్ట్ హాప్ సెల్ఫ్ అని చేసేసి ఏమవుతుంది, ఈ నైబర్ R1 నైబర్ ఎవరు 3 కదా, ఈ నైబర్ 3 ఇంజెక్ట్ చేసి పంపిస్తుంది. ఇది చెప్పా కదా నిన్న మీకు, గుర్తులేదా, మర్చిపోయారా?
Yes, yes.
ఓకే, ఇక్కడ 3 సరే, ఇక్కడ సరే నెక్స్ట్ హాప్ సెల్ఫ్ కాన్ఫిగర్ చేయలేదులే, వదిలేసాయి. నెక్స్ట్ హాప్ సెల్ఫ్ నువ్వు కాన్ఫిగర్ చేయలేదు, లెట్ ఇట్ బి. సో ఇట్ విల్ అడ్వర్టైజ్ 35.5 ఓన్లీ. So now tell me, R3 is advertising this EBGP route to IBGP peer R1. Now the next hop remains the same. It will not change. It will be 335.5 only. It will not be 3.3.3. Okay, because you are advertising EBGP prefix into IBGP peer. This is IBGP peer kada R1. So that's why the next hop will be remains same. Also this IBGP peer in the within the same AS 200 only. That's why it will not carry the any AS number. When it will carry the AS number, when it is crossing the AS, it will carry the AS number, then it will change the next hop value. Now it is not changing the, now it is not crossing the AS number, right? That's why it will not carry anything. Everyone understood what I'm saying? Hello, అర్థమైందా everyone?
Yes, yes.
Guys, no one is answering means no one is understood. సైలెంట్గా ఉండే బదులు అర్థం కాలేదన్నా చెప్తే అన్నా మళ్ళీ చెప్తాం కదా, ఎందుకు సైలెంట్గా ఉంటారు? నాకు నచ్చంది ఇదే.
అంటే అది ఓన్లీ
చెప్పండి, నేను చెప్పండి చెప్పండి.
అడ్వర్టైజ్ చేస్తేనే కదన్నా మనకు అది వచ్చేది ఏ స్పాట్ నెంబర్.
ఇప్పుడు R3 ఉంది, R3 నైబర్ ఎవరు? R1, రైట్? ఈ R3 R1 దేంట్లోనే సేమ్ ఏఎస్ లో ఉన్నాయి కదా, సేమ్ ఏఎస్ నెంబర్. మరి ఎందుకు ఏఎస్ నెంబర్ ఎందుకు యాడ్ అవుతుంది సేమ్ ఏఎస్ లో ఉంటే? వాట్ ఐ సెడ్, ఒక రౌట్ ఒక ఏఎస్ నుంచి ఇంకో ఏఎస్ కి చేంజ్ అవుతే ఏఎస్ నెంబర్ యాడ్ అవుతుంది. ఇట్ మీన్స్ this route is changing from one AS to another AS, then only it will prepend the AS. Now it is advertising to its internal peers. Why it will add AS path, right? Similarly, this next hop also will not change. Next hop also will remains the same. So the attributes will not change when it is advertising to its internal peer. Is it clear? Whatever the attributes, next hop, AS path, right, will not change when it is advertising to the internal peer. Is it clear, guys? Now everyone,
Okay.
attributes
Yes.
will not change when it is advertised to its internal peer. Simple. Okay, now R1 is again advertised to R4, right? When it's tried to advertise, it will prepare the AS now, because now it is in AS 200, it is changing to another AS 100. So it will add AS 200 now,
200.
and it will send to Tata. Now you will come to know. So R4 receives this route, it will check the AS path is 100. Hey, this 4.4.4 is I advertise it to you, and again it is coming from R1. Someone is next up, so 35.5, he is announcing the 4.4. Owner is 35.5. No, I'm the owner of 4.4.4. Who is this 35.5? Who the hell is he? Why is announcing himself as a next op for this 4.4.4? 4.4.4 is belongs to me. And if you see the AS path, right, see, this is a proof. It is leave from my AS 100. So if R4 receive any EBGP prefix, it will check the AS path. In this AS path, if it sees in own AS, it means loop. Yes or no?
Yes, sir.
Now loop is happened, right? How loop is happened? So it sees its own AS in the BGP route. Yes or no? Hello?
Yes, sir.
Yes,
So
yes.
that's why it is preparing the AS. While preparing the AS, it will see its own AS. So when it sees its own AS, this route will be not installed in the routing table. It will be cancelled. Understood? It cannot accept, because this has been hello, can you hear me? Yeah. So this has
Yes.
been generated by me, and you announcing yourself as this is my route. So that the simple thing is, if it sees its own AS in AS path, it consider it's a loop, and it will not install this, you know, route in your routing table. Okay, it will cancel it. Is it clear?
Yes, sir.
Okay. I want to do something here and it is playing with me. Oh my goodness.
సో సో డిఫరెంట్ అటానమస్ సిస్టమ్స్ ఏఎస్ పాత్స్ మధ్యలో అయితేనే అది క్యారీ చేస్తుంది. రౌట్ అయినా సరే లేదంటే ఈ ఏఎస్ నంబర్ అయినా సరే పాత్
That's
అలా క్యారీ చేసినప్పుడు ఏఎస్ పాత్ లో
no,
దాని
no,
ఓన్
no.
నంబర్ అయితే
It's not like that. It's not like that. The BGP prefix carry the route along with the attributes. The rule is it will prepend the AS path. In case if it sees its own AS, it consider okay, this route is advertised by me. Again, you are advertising from other side, so it's not good. So see, it sees its own AS means this route is belongs to me. So if it accept it, it will trigger a loop. That's why what it will do, if it sees its own AS, then it will stop. It will not install in your BGP routing table. Okay, it will avoid it completely. Okay, so
ఓకే
how
సార్.
the loop
ఓకే.
avoidance will be happen? Now the interview question, how the loop avoidance will be done in EBGP?
AS numbers.
బై
Yeah,
సీయింగ్ ద ఏఎస్ పాత్.
very good. By preparing the AS path, remember, it will prepare the AS path. Interview questions, they will ask you like this. How loop avoidance will happen in EBGP? So whenever the EBGP prefix advertised to another AS, it will prepare its own AS. Okay. If it receives any BGP prefix with its own AS, right, it will not allow you to install. That's how it will avoid the loops. In case if it is allowed, right, this R4 will have a two paths. 4.4.4 is directly connected is one path. 4. To reach 4.4.4, I need to reach 35.5. Okay. Some packets it will go to the 35.5. Who is 35.5? It cannot understand, right? The router will confuse. So that's why it will not install because the 4.4.4 is already it is my route only. So loop means you have it one destination, you have a two paths. So in routing table, you know, it will fluctuate it. To reach one destination, first you need to go this way. Immediately it will switch it. Suppose, you know, what do you mean by loop? You know, real time I'll tell you. Real time I'll tell you. This is a Google Maps. Everyone's seeing it, right? Google Maps. Okay. Are you seeing my screen? Okay. Okay. What is this? So let's do Bangalore. So let's get directions from Bangalore to Hyderabad to Bangalore. Okay. How many routes it is showing? 3 routes, right? Yes or no? Okay.
Yes, sir.
Just
Yes, yes.
forget about red wala. It's a something aviation stuff something. So you will see 2 routes. So while traveling Hyderabad to Bangalore, right? So your Google Maps will fluctuating, like sometimes it is saying this route, sometimes it is saying this route, sometimes saying it is this route, sometimes it is this route. So what you will decide? You will get confused or not while traveling it. What is your
Yes.
Yes.
destination? What is your destination? Your destination is Bangalore. To while traveling Bangalore, if it shows only one path, it is okay, you will follow one path. But while going to destination, some packets it is going to via this path, some packet is going via this path. How you will you know, you will confuse it. So in real time also, this R4, right? Suppose R4 try to reach R5. If it loop happens, it will tell you have to reach via R1, you have to reach via R4. So some packets, ICMP packets, right? Some data, the data will not send you at a time, right? Suppose 4 MB of data is there, it will divide into the chunks. Some chunks will go into R1, some chunks will go into R6. So somewhere it will be drop, right? The chunks will not, the data will not receive at the receiver side. So it will be a huge problem. If the loops is happening, right? Your network is not stable. So if you want to, your network should be stable, it should be follow only one path. Forwarding is one path, reverse path is also, it should be same path. Understood, guys? Is it clear? Okay. So because of loops, so that is a disadvantage of the loop. Disadvantage of the loop. Okay. So how you will avoid the loops in EBGP? By preparing the AS path. Is it clear? Why it is preparing the AS path? because to avoid the loops, how it will avoid the loops? If it sees its own AS, right, it will not inject the route in its routing table, so that it will avoid the loops. In case if it is accepted, what will happen? It may have two next hops. So like two next hop in the sense, to reach one destination, two next hops. Some packets will go in one path, some packets will go in another path, so that the packets will not deliver to the destination. Okay, is it clear? Hello, is it clear?
Yes, Anna.
Yes, sir.
Okay, that's all about EBGP path manipulation. It's not path manipulation, AS path prepend. Now in IBGP, this color, right? Whatever you see, this sky blue, whatever, what color it is, I'm not sure. Is it which color, blue or sky blue or what? Sea blue, right? Something like that. So whatever the color it here is, this is called Infosys campus. It's a IBGP. Now, how you will avoid the loops in IBGP? Okay, you tell me. So how loops will occur? I'll tell you. Okay, suppose you have a peering, right? R1 to R2, R1 to R3. Yes or no? Yes or no?
Yes, sir.
Okay, show IP BGP summary. Show IP BGP summary. So if you see show IP BGP summary, how many neighbors I have? IBGP neighbors 2.2.2 and
2.
3.3.3, right? So 2.2.2, 3.3.3. Now listen carefully. Okay, IBGP update. Where the routes will carry update message. Update message, you will see the routes. Now if you see, right, if R1 sending a IBGP update to R2, the same IBGP update will not send to R3. That is called split horizon rule. What do you mean by split horizon rule? Split horizon rule. So what do you mean by split horizon rule? If R1 sending a IBGP update to R2, the same IBGP update R2 will not send to, it will not send to R3. That is what split horizon rule. Because of that, loops will be stopped in IBGP domain. In case if it is sent to IBGP update, right? R1 sending IBGP update to R2, the same IBGP update will send to R3. R3 also will do same thing, right? It will send IBGP update to R1 because between R1 and R3 we have a BGP neighborship. Yes or no? See, we have a BGP neighborship between R1 and R3, right? So it means whatever you are sending to R2, the same IBGP update it is coming from R3 as well. It is called loop. Understood? Hello, is it understandable?
Yes, yes, sir.
Yes, yes.
A simple logic, man. I'm telling you. So R1, see, R1 is having a neighborship with 2.2.2 as well as 3.3.3, right? 3.3.3 is a indirect. These are our indirect neighborship only. Okay, neighbor. So routes will exchange to the neighbor only, right? So R1 will send a IBGP update to R2. Okay, so if R2 will send the same IBGP update to R3, right? What will happen? R3 will also send the IBGP update to R1, so that the loops will be triggered. It means whatever the IBGP update I am sending to the peer, it is sending back to me only from another peer. This is called loop. To avoid this loop, there is a concept called, if I advertise any IBGP, only IBGP update. If I am advertising any IBGP update to another IBGP peer, that IBGP peer will not advertise to another router. So that it will be here only. Okay, this is called split horizon rule. By using split horizon rule, you will avoid the loops. Everyone understood what is split horizon rule? The definition of split horizon rule is an IBGP router will send a IBGP update to another IBGP router, that is called R2. The R2 will not send this IBGP update to R3. That is called split horizon rule. To avoid the loops, it will do like that. In case if it is sent right, R3 also will send to R1. Then loops will trigger like this. It is keep on advertising the updates like this, and you won't see a stable routing table. Guys, you're so silent. Am I explaining any alien technology? Again, you're silent. You didn't understand what I'm saying.
క్లియర్ అండి అర్థమవుతుంది.
Understood, Anna.
మరి అదే అడిగిన నాకు ఏదో ఒకటి అక్నాలెడ్జ్మెంట్ కావాలి. ఐఎమ్ ఏ కైండ్ ఆఫ్ ఏ టీసీపీ గాయ్. If I'm telling anything to you, you should acknowledge. Otherwise, then only I will send the next topic. Otherwise, I cannot do. I cannot retransmit, until you give any acknowledgement. Not like it completely TCP guy. Okay. సో ఏదోటి అర్థం కాలేదు అర్థమైందని చెప్తే నేను మళ్ళీ చెప్తాను కదా. సైలెంట్గా ఉంటే ఐ డెఫినెట్లీ అండర్స్టాండ్ యూ డిడెంట్ అండర్స్టాండ్ అని. సో స్ప్లిట్ ఆర్జన్ రూల్ అంటే అర్థమైందా?
Again,
సో
yes.
బీజీపీ మెసేజ్ లో అప్డేట్ మెసేజ్ అనేది ఒకటి ఉంటుంది. వాట్ ఆర్ ద బీజీపీ మెసేజెస్? దెర్ ఇస్ అప్డేట్ మెసేజ్, రైట్? In that update message only you will see the routes. Yes or no? Hello?
Yes.
ఎస్ అన్న.
Yes.
But no.
Right? So if R1 sending any IBGP update to R2, the same IBGP update you did not send to R3. That is called split origin rule. Because of this, loops will not happen. How loops will be avoided in IBGP? Because of the split origin rule. Okay? So if you see, right, IBGP update will go to R2 only. It will not send to R3. In case if it is sent right to R3, again R3 will send back to R1. Then hence loop will trigger, right? That's why split origin will stops it. So that's why you need a full mesh. What you need? You need a full mesh. You need to establish a neighborship with R1 to R2, R1 to R3, so that it will send it two IBGP updates. It will send one IBGP update to R3. It will send another IBGP update to R1, R2 and R3. Individually it will send. Okay, it will send individually. So full mesh is required here because of the split origin rule. Okay, split origin rule will not send an update to another IPGP pair, right? So that's why full mesh is required, so that each peer will send exchange their updates each other. Is it clear? So
Yes.
how you will avoid the loop in EBGP? By preparing the AS path. How you will avoid the loop in IBGP? By split origin rule.
Horizontal.
Okay, yeah. Now this is it. This is all about it, guys. Okay, so yeah, so these are the very important things. Now attributes. So how many attributes we learn? These are the things. Now next one is local preference, guys. Local preference. So this is very important. So I will explain you theory. After that I will give you 1 hour video. Just do watch that video and implement the lab. Okay, so local preference. What do you mean by local preference? Suppose you're working in Infosys. I'm on R2. I'm on R2. So local preference will only applicable for IBGP only. It will not carry in EBGP. That's why local preference is called discretionary. Discretionary means it is mandatory. It should understand by every router, but whether it will carry or not, it's not mandatory. It's mandatory to understand, but it's not mandatory to carry. It is discretionary. Okay. If you see, right, if EBGP peers, you will only see these three attributes. You will not see local preference. Local preference you will see only in IBGP peers. If you see, right, here. Let me check show IP BGP table. Show IP BGP here. If you see 4.4.4 is the EBGP peer. That's why you will see next stop, AS path and origin. But 5.5.5 is IBGP. 5.5.5 is learning via IBGP. See show IP route. If you see 5.5.5, it is learning via IBGP. IBGP administrative distance is 200. So that's why if you see show IB BGP, it is learning via 3.3.3. How it is learning? You apply the text of self, right? It is learning via R3. It's IBGP peer, right? సో 5.5.5 అనే రౌట్ 3.3.3 నుంచి లర్న్ చేసుకుంటుంది. 3.3.3 అనేది ఏంటి? ఐబీజీపీ పియర్ ఐపీ, రైట్? ఇట్స్ ఐబీజీపీ పియర్ ఐపీ. 5.5.5 is learning via IBGP peer. That's why you will see local preference. Okay, the local preference you will see only internal IBGP peers, not with external IBGP peers. Understood? So that's why it's a
Yes,
well-known discretionary. Now, so local preference is the attribute. It will tell you how to exit your AS. Now I'm on R2. I want to reach AT&T. AT&T loopback IP address is 6.6.6. I want to reach AT&T. So by default, you may be reach via Tata. Okay, maybe this is the best path. How it is selected? You have two paths to reach the 6.6. Yes or no? In BGP environment, You have two paths to reach the 6.6.6. So which path it will select? I will tell you the path selection process. Please focus on it. Okay. What is the BGP path selection process? This is the path selection process. Okay. First, if you see here, right? First, the next hop should be reachable. Next hop means neighbor IP. The neighbor IP should be reachable. It means if I want to reach 6.6.6, what is the neighbor IP? Next hop. It will carry the next hop IP, right? That IP address should be reachable. It may be 1.1.1 here. So it should be reachable. Yeah, it will reach. Okay. And now the next one is highest local preference. So if you see here, right, 6.6.6 is received on R2 router. Suppose you can say let's 6.6.6. I'm just giving an example. 6.66 received on R2 router. One is via next hop 1.1.1. Okay. Local preference is 100 and 6.6.6 it is learning from next another next hop is 3.3.3 and LP is 200. Now which one it will prefer? It will go via R1 or R2. So whichever having the highest local preference, it will prefer,
The with the
200.
200, right?
3.3.3.
3.3.3.
right? It will choose 3.3.3. So now local preference importance is it will tell you how to exit your AS, how to exit your Infosys campus. So you have two internet connections. One is Airtel, one is Tata. So your data, your all your internet, your all your user traffic will go via Airtel only here, based on the local preference. Who will decide it? Local preference will decide it. Local preference is the attribute. It will tell you how to exit your AS. How many employees in your company Infosys? There are 10,000 employees. There are 10,000 computers. All 10,000 people are using Airtel internet here. Understood? Is it clear? Hello.
Yeah, yeah, it's clear.
Local preference is the
అదే
important
మనం
thing.
కన్ఫిగర్ చేసుకోవచ్చు అన్న లోకల్ ప్రిఫరెన్స్.
Yes. That's what I'm telling you. Now, you don't want to go via Airtel. You want to switch the path to Tata. Now, what you want to do, you need to change the local. By default, local preference value is 100. Now, you need to change it. So, Airtel, you will change to, you can change to 300. Whether you will change to 300 or else whether you can change the value here 99, something like that. Okay. Change the 99. Okay, you can change it accordingly. So if you want to send all the traffic to Tata, change it to 300 and here it let it be 100, like that. You can change it accordingly. How you will change? By using route maps. This is called path manipulation. So I will give you the video. You have to do that. I'm not going to explain that. Okay, you must do it. Watch that video. After this video, I will give you that path manipulation video. You just do it. Okay, understood? It's very simple. You do it. Okay. Yeah.
ఈ
So
రేంజ్ ఎంత ఉంటుందన్న లోకల్ ప్రిఫరెన్స్?
local preference range you can give anything. So 65,535 వరకు ఇచ్చుకోవచ్చు, ఎంతైనా ఇచ్చుకోవచ్చు. ఓకే, సింపుల్ బ్రదర్. టూ ఐఎస్పీస్ ఉన్నాయి కదా, రేంజ్ ఎందుకు ఇంకా నీకు ఇక్కడ? ఒకటి ఒకటి ఎక్కువ ఉంటే ఒకటి తక్కువ ఉండాలి. నీకు టూ వాల్యూసే కదా కావాల్సింది.
ఇన్ కేస్
అవునా?
3 ఉన్నాయి, 3 నెట్ అంటే 3 ఐఎస్పీస్ ఉన్నాయి. సో
3 ఐఎస్పీస్ అనుకో,
ఒక
400 ఇచ్చుకో, అక్కడ 400 ఇచ్చుకో.
ఓకే,
ఒకటి
ఇప్పుడు
100.
ఒక 400 ఇస్తాను, ఒకటేమో 100 ఇస్తా. సో 400 ఉన్న లైన్ కట్ అయిపోయింది. ఆటోమేటిక్గా
యా
100
నెక్స్ట్
నుంచి
నెక్స్ట్ ఏదైతే ఉందో అది ప్రిఫర్ చేసుకుంటుంది. యా నెక్స్ట్ ఏదైతే ఉందో అది ప్రిఫర్ చేసుకుంటుంది. సో ఇప్పుడు ప్రైమరీ పాత్ ఇది ఏమవుతుంది? ఎయిర్టెల్ అవుతుంది. సెకండరీ పాత్ ఏమవుతుంది? టాటా అవుతుంది. నువ్వు అన్నట్టు ఇంకో ఐఎస్పి ఉంది, 6.6.6 ఉంది. సో దాని నెక్స్ట్ టాప్ వచ్చేసి ఇంకొక రౌట్ ఉంది. నెక్స్ట్ టాప్ ఏంటి? ఇంకోటి 4.4.4 ఉంది అనుకో, జస్ట్ సింపుల్. దీని ఎల్పి వాల్యూ నువ్వు అన్నట్టు 200 ఉంది అనుకో. సో ఇట్ విల్ చూస్ దిస్ పాత్. ఇది సెకండరీ అవుతుంది, ఇది ప్రైమరీ అవుతుంది. అదే ఇప్పుడు నేను చెప్పబోయేది. నౌ దిస్ ఈస్ ద థింగ్. సో సో నెక్స్ట్ ఏంటి? స్మాలెస్ట్. సో దిస్ ఇస్ ద పాత్ సెలెక్షన్ ప్రాసెస్. ఇప్పుడు నువ్వు చెప్పేది నేను చెప్తున్నాను చూడు. How it will select the path? This is the scenario. So BGP path selection process. So first it will check next hop should be reachable. Second it will check what is that? Okay. Warning. Oh, 1 second. Yeah. Now second it will check Second, it will check next hop reachability. Second, it will check whatever the highest local preference that will prefer. Third, will check shortest AS path. The AS path value, whichever having the shortest AS path, it will choose as the best path. Next is smallest origin. It means if it is I, it will prefer. If it is question mark, it will be preferred later. First, I will be preferred. Next, smallest MBD value. What do you mean by MBD? It's a attribute you will see in multi-exit discriminator. It means suppose you have a router and you have a connection with data. You have only one single link here. Let's connect one more link here. Two links. It means it's called multi-exit discriminator. If you have a connection with ISP with two physical interfaces, this is called multi-exit interface. Okay. So here you will see MBD value. You will see MBD between only EBGP peer only, not IID. So whichever having the lowest MBD value, either here or here, whichever having the lowest MBD value, that will be preferred. Okay. So multi-exit discriminator. So lowest MBD value will be preferred. Next is EBGP route will preferred over IBGP because EBGP AD value is 20, IBGP AD value is 200. Right? If you see here, what is the AD value of IBGP? 200, EBGP 20.
20.
Is it clear? So which one it will prefer? It will prefer EBGP only. The next means smallest IGP metric to reach the BGP. Next hop. Smallest IGP metric means IGP means the sense OSPF. Suppose here I configured OSPF. So now R1 neighbor is 3.3.3. To reach 3.3.3, you have only one path. Now I have one more path here. Let's connect one more here. So I have one more path here. Okay. I have one more path here. So what is the metric value here? So suppose here the metric value is to reach R1 to R3. R3 3.3 is my neighbor. So what is the metric OSPF metric here? 1 and 2. Here only 1. So what is the smallest IGP metric here? This is 1, right? So whichever having the smallest IGP metric, that route will be preferred. So just remember only these 7 points. So in interview, they will ask you what is the BGP path selection criteria. So next stop should be reachable, highest local preference, shortest AS path, smallest origin, MBD value, EBGP preferred over IBGP, smallest IGP metric. So this is a process. This is how it will elect the best path. Now you tell me this is the exercise. You have 1, 2, 3, 4, 5, 6, 6 routes to reach the 10.0.0.8 is the destination. Nikki 6 paths. You have 6 paths to reach the 10.0.0.8. Now tell me which route it will, which path it will prefer. You have peers, 6 peers, A, B, C, D, E, F. Now, which peer it will choose? Peer in the sense internet connections you can consider. IP, BGP peer IP. Okay. To reach 10.0.0, you have multiple peer IPs. Which one it will choose? Now tell me. Now, the first one is next hop reachability. Yeah, next hop reachability is there. Now, second one is highest local preference. Which one is having highest local preference here?
200. Here,
200,
everything
right?
like these are
200,
having the
right?
same.
Yeah.
Inches per
So,
Yeah.
so this B, C, D, E, F all are having 200 means this is low, right? This will be removed here. So now it will tie here. Local preference is tie. So then it will go to the next one.
It will choose the B.
So shortest AS path. What is the shortest AS path between them?
It's same.
Shortest AS path. So
B.
this is having 4. Yes or no? This is
son.
having 3. So it is having
B
4. This is
or
having 3. So it will cancel this and this. Remaining 2. It is having
Having
B D E. B D
B.
E. Yeah, B D E. So out of B D E it will choose. Now AS path is also tie. Now, which one it will choose? Smallest origin value. I it will
That is
prefer.
I.
So which one is
Yeah.
having I? I
A,
think
B, and
not A.
BD.
A is already cancelled. BD is having I. E is
B
cancelled.
and B.
So now
question
you,
mark community.
yeah, you can
Cancel.
remove this. Now it would be either B or D. So what is the smallest MBD value? Which one is having smallest
B.
MBD?
B and
B.
B. So
B.
the best path is this. Understood now? You have multiple
Yeah.
paths to reach
yes,
the
no.
destination. This is it. This is called BGP path manipulation process. Okay.
Yeah,
So
these kind of questions will be in the exam.
yeah, this kind of questions will be in the exam.
Okay.
Okay. Yeah, and the thing is, guys, these are the BGP attributes. How many attributes you learn? They will ask you. You need to tell only this: ace path, next stop, origin, local preference, and MBD value. Just tell them only this. Okay. It will be, and it will be good for you. Okay. This is next level training, guys. And now one more thing is, so if you want to do path manipulation, right? I'm going to give you one more video. Same thing, you just implement it. Go to Google. Here I just take BGP real time project. You just give hashtag of Tungabhadra networks. See this part 1 and part 2. No one made a real time project videos on this. It is showing in YouTube my video. Okay, so this is part 2 video. Part 1 is the one which we did it. So go this. So I'm going to share this. Okay, here I explain route maps and ACLs as well. So by using this video, advertise it. Okay, is it clear, everyone? Hello.
Okay, sir.
Whether you
Yes.
can
Sir,
either you can watch this, as well as you can do one thing. Go to my website Tungabhadra Networks. Training videos are already there, right? You know the password. Go there and give the password. And here, where here, go to the recorded sessions. Here you will see BGP. BGP peer groups, path selection process. Watch this video. Okay, watch this video. It's the same video which we discuss currently. Okay, same video. Yes or no? Same video which we discuss currently. The only thing is colors. Okay, please watch this video and complete your lab. Okay, now route reflectors also I explained here.
sir.
Okay, yeah, it's a beyond the scope, guys. Okay, yeah. So if you have any questions on path selection process, let me know. Okay.
Yeah. I have only one question. For you said like the starting router the 6.6. So the next hop every time we are taking 3.3, why not the Tata thing? Because it is passing through that.
I didn't understand your question. You mean why not
Uh,
Tata? Okay.
like for this one, the next hop we took 1.1.1, the local preference 300.
Yeah. See,
Why
see,
we have not
that's what I
taken the
told you,
next
right?
hop as this?
It's a path selection process, yeah. So BGP path selection process, whichever having the highest local preference, that will choose that. Now 1.1.1 is having a highest local preference. It will choose the path via. It will go via R1 to Tata. Okay.
Okay.
Currently all the traffic will go via here. What is this? Okay. So it will go via like this. In case if the local preference of 3.3.3 is 400, now it has very big. Now it will choose 3.3.3. Understood? It depends on
No,
local
this
preference.
one we mentioned next hop is 1.1.1. That is also through the BGP path selection
Sir,
process.
what is mean by next stop, Pooja? You tell me. What do you mean by next stop? Next stop?
The next router thing.
No, 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 not next router thing. Can anyone please tell me what is next stop here?
Neighbor అన్న.
Neighbor IP
Like,
address. Neighbor IP
yeah,
address. So, so how exactly who is advertising this 6.6.6? 6.6.6 advertising to. So this 6.6 is advertising from R1 neighbor as well as R3 neighbor here. Okay, these are the BGP neighbors. Okay, both are advertising. That's what the just now you told, right? You corrected the answer. The path selection process. Peer
yeah,
A, peer A in the sense neighbor A. Here there are peer A, B, C, D, E, F. In this topology, you have only two peers. One is peer
yeah.
1.1.1, another peer is 3.3.3. Between these two, which one it is choosing? Based on the highest local preference, it is choosing.
Okay.
Understood or not?
Yes, yes.
So if you see this, right, here there are peer A, peer B, peer C. There are six peers, BGP peers. For R2, right? So this is R2. For R2, if you see, show BGP summary. How many peers are here? Only two, right? Here there are six peers. Within these two, which one it is? It will choose. It will choose whichever have the highest local preference. It will choose. Okay. Show IP BGP based on the path selection criteria. it will choose. So based on the path selection criteria, in the sense highest local preference. If the local preference is tie, it will go to the shortest AS path. It will go to the AS path is tie, it will go to the origin. This is the steps. If all tie right, it will go till 7. So yeah, understood or not?
Yes, yes.
So what is your question, Pooja? I didn't understand that.
My question was that only, so the label for R6 can be R4 also, or
What do you mean by R6 can be R4? Why should R6 can be R4? Why? How come it will be
the
R6?
network?
I didn't understand. See, the agenda is this is your Infosys company. In this Infosys company, you have two internet
Yeah,
connections. So,
yeah.
from your mobile, you have Airtel and Jio generally two SIMs, right? So, which one you selected as a primary, you'll get internet connection. Manually, you are selecting it, right?
Okay.
Similarly, organization is getting internet connection from Airtel. So, how it is choosing the path based on the path selection process here. Okay, so these are the edge routers. These routers are advertising this 6.6.6 to R2. R2 is
Okay.
receiving. R2 is receiving 6.6.6 from
Okay, got.
1.1.1 to 3.3. Each one having local preference values. Based on the local preference value, it will choose. If the local preference value is
Okay.
high, it will move to the next path selection, next criteria. Like that, it will
Okay.
select. It will check all the criteria and it will choose the best path accordingly. Okay.
Got it. Yeah.
So I'm just telling you about best path selection. Now, if you want to manipulate the path, currently if it is going via this path, if you want to manipulate it, you have to do path manipulation. This is a video. Okay, this is a BGP path manipulation video. Okay, yeah. So BGP path manipulation, if you want to do it, guys, by watching that video, you'll come to know. So watch that video, real time project video. This is one scenario. This is just a, this lab is just for a lab. So if you do real time project, na, like this is good. This is real time. Really, we implemented this. I recommend you to build this lab. Okay, do it.
Okay, okay.
Build this lab and do it. Okay, these are the computers. These are the Google server. I built this lab. I did a trace out and I did a lot of stuff. Okay, do it. Okay, yeah. If you do this real time lab with BGP, you'll be perfect. Okay, yeah. That's all for today, guys. Thank you so much.